Hello, test. Okay. Can this go while the screen recording is going? Yes. Okay. Um, very sorry for the split screen here. I just needed to make sure. Oh no, this might work. Okay. So, for this video, I chose to do Power Number 9, and I wrote a sign here. So it asks, an inquisitive physics student and mountain climber climbs 52-meter high cliff that overhangs a calm pool of water. He throws two stones vertically downward, 1 second apart, and observes that they cause a single splash. The first stone has an initial speed of 1.86 meters per second. So, part A asks how long after the release of the first stone do the two stones hit the water. So, before I got all of this started, I drew a little picture. So here is a man on a cliff, and then stone 1, stone 2, and we are going downward. And I've signified for easier purposes that my down is going to be positive. So, I listed out my givens just to make everything a little bit easier for me. So I have the initial velocity for stone 1 is 1.86 meters per second. The acceleration is 9.8 meters per second squared. And then my displacement is 52 meters. Now, I was looking at everything that I was looking at what I needed to find, and the easiest solution was to use that third kinematic equation, which I've written up here. Displacement equals initial velocity times time plus 1/2 acceleration times time. Now, I plugged all of my givens in, and I got 52 meters equals 1.86 meters per second times time plus 1/2 9.8 meters per second squared plus time, or times time squared, sorry. I multiplied what I needed to, I moved over what I needed to, and I got the equation 4.9 meters per second squared times time squared plus 1.86 meters per second times time minus 52 meters equals 0. Now, I realized that I can factor this. Now, the two answers that I got for this was 3.1, and the other was negative 3.5. So, time cannot be negative, therefore my answer was 3.1. Now, for part B, it asks what initial velocity must the second stone have if the two stones are to hit the water simultaneously at the same time. So, because it shows in this problem that they were thrown downward, so the direction for that is going to be downward, but they were thrown 1 second apart. So, we found out the time for the first stone. Now, to find the time for the second stone, we have to subtract that 1 second. So, 2.1 seconds minus 1 second equals 2.1 seconds. Now, I listed out my givens again here. That time is 2.1. I have acceleration 9.8, and displacement is 52. Now we're going to use the same kinematic equation. However, this time instead of finding time, we are going to be finding the initial velocity. So, 52 meters equals initial velocity times 2.1 seconds plus 1/2 times 9.8 meters per second squared times 2.1 seconds squared. I added, multiplied, moved over what I needed, and I got 52 meters equals 2.1 seconds times initial velocity plus 21.609 meters. Now, I want to isolate this here in order to find it out, so I just subtracted by 21.609 meters, which gets me to here. So 30.391 meters equals 2.1 seconds times velocity, initial velocity. Now to isolate this even more, I divided both sides by 2.1 seconds. This here cancels out, and so I'm then left with the initial velocity of stone 2 being 14.4 meters per second. And as I said before, we are going downwards. I just undid something that I needed. And then my last question here is, what is the speed of each stone at the instant you sink to the water? So I need to find my final velocity. I looked back at my kinematic equations, and I determined that this one here would be the best, and it has everything that I need. So final velocity equals initial velocity plus acceleration times time. I have listed out all of my givens again. So for the first stone, we have 1.6 meters per second. Acceleration is 9.8 again, and the time is 3.1 seconds, because again, it's the first stone that we are working with. So the final velocity of the first stone equals 1.86 meters per second plus 9.8 meters per second squared times 3.1 seconds. I multiplied, I added, and I got 32 meters per second. So that's for the final velocity for the first stone. And now I have the final velocity for the second stone. I've listed out my givens again over here. Remember, we are going to use 2.1 seconds this time because of that subtraction, and the 14.4 is what we got from the previous question. So I plug that in. We got the final velocity. Oh my gosh, sorry. The final velocity of the second stone is 14.4 meters per second plus 9.8 meters per second squared times 2.1 seconds. I added, I multiplied all that fun stuff, and I got 35 meters per second for the final velocity.
Okay.
So in order to show that I understood this and I wanted to, go more into the understanding of this, I drew out to get the relationship, I drew out a velocity time graph. So this is more zeros, but as you saw, when time went up, velocity also went up, and that we can see actually in our last. In this here, we saw that the final velocities were significantly higher than the initial velocities. The reason this tripped me up a little bit was because of this 1 second here. In the original problem, I did not actually manage to get the magnitude, which I did find, or the first and second stone, like the final velocities for those, but I figured this out, and yeah.